This question was asked in the GATE Physics paper 2020. This is a MCQ type question having 1 mark, and the topic of the question is electromagnetic theory. The question is, if E vector and B vector are the electric and magnetic fields respectively, then E dot B is option A, odd under parity and even under time reversal, option B, even under parity and odd under time reversal, option C, odd under parity and odd under time reversal, and the last option, option D, even under parity and even under time reversal. So let us see how to solve this problem. So E vector is the electric field vector, that is polar vector. So polar vector is related to the direction of motion of a system, that is translational motion, and that has a particular starting point. But magnetic field vector B vector is an axial vector or pseudo vector. So what is the axial vector? It is related to the direction of rotation of body. It doesn't have any starting point, only it has a direction along an axis. Now we will be talking about the parity operation and time reversal operation. First, starting with the parity operation. Parity operation or the transformation is the space inversion or reflection. It means flip in the sign of spatial coordinates. So if we consider p cap as a parity operator, so it will turn the position vector r vector into minus r vector. So it will flip the sign. Now we will be talking about time reversal operation. It means the operation of replacing the time with its negative value. That means t will become minus t. So that it indicates an phenomena in which time runs in backward direction or all the motions are reversed now. So if t cap is the time reversal operator, so it will give minus t upon acting on the time. Now consider a particle of charge q moving with a velocity v in an electric field E vector and magnetic field B vector experiences a Lorentzian force that is given by this expression. Force F vector equals to q times the electric field vector E plus V cross B. Now force can be written as mass of the particle times acceleration, and acceleration is d2r dt2. Now if we replace the r vector, that is position vector, by minus r vector, then the force will be m times d2 of minus r dt2, and that will give minus of m d2r dt2. So this will be basically minus of force vector. Now if we replace the time by minus t, then force vector will be m times d2r d of minus t square. So this will be m d2r dt2, and that is same as the force vector, that is F vector. So what we have learned, if we operate the parity operator on the force vector, so that means force vector will flip its sign under space inversion or deflection. So this will become minus of F. But under time reversal operation, the force vector doesn't change its sign. Now coming to the Lorentz force, that is F vector equals to q times E plus V cross B. Now charge doesn't change its sign under parity operation as well as time reversal operation. So in this force there are two parts, one is electrical force, one is magnetic force. So we will denote it by 1 and 2. Under parity operation, F will change sign, that we know already. So from that information, in this part 1, the E will flip its sign because F is changing its sign under parity operation. So E will obviously change its sign. In 2, Q into V cross B will flip its sign under parity operation. Now V, that is velocity, is dr dt. Under parity operation, V will change its sign, that is minus V. because r is replaced by minus r here. Now under time reversal operation, the velocity will also change its sign. So it will become minus v. Now in 2, the term q into v cross b under parity operation, it will change its sign because force will change its sign. That means it will also change its sign this term. It means the magnetic field vector will remain unchanged because velocity is changing its sign. That will give the negative sign here. So B has to be invariant under parity operation. So what we have learned till now, under parity operation, the electric field vector changes its sign. So it is odd under parity operation, but magnetic field vector doesn't change its sign under parity operation. So it is even under parity operation. Under time reversal operation, the force vector doesn't change its sign, but the velocity vector changes its sign. So it will turn into minus v under time reversal operation. So this suggests that the electric field vector E will not change its sign under time reversal operation, but the magnetic field vector will change its sign under time reversal. So magnetic field vector will change its sign because here V is also changing its sign under time reversal operation, and magnetic field also changes its sign under time reversal operation, and both this cross product will become positive under time reversal operation. That means force will not change its sign. So what we have learned, electric field vector doesn't change its sign under time reversal operation, so it is even under time reversal operation, but magnetic field vector changes its sign under time reversal operation, so it is known as odd under time reversal operation. So in a summary, what we have, under parity operation, E, that is electric field vector, flips its sign, so it will become minus E vector, but under time reversal operation, it doesn't change its sign. In the case of magnetic field vector doesn't change its sign under parity operation, but under time reversal operation, it changes its sign. Now coming to the main part, that is the dot product with electric field vector E and magnetic field vector P. Under parity operation, on this E dot B, that quantity, it will give minus E dot product with B, because parity operation will give minus E, but B will remain the same. Effectively, under parity operation, the quantity E dot B will become minus E dot B. So this is odd under parity operation. Now we will operate the time reversal operator on this quantity E dot B. The time reversal operation will give E as E vector. So E will not change here, but B vector will flip its sign. So it will become minus B vector. Effectively, we will get minus E dot B. So under time reversal operation, it is also odd under this operation. So effectively, what we are getting under parity operation, E dot B will become minus E dot B, that is odd under parity operation. And under time reversal operation, this quantity E dot B will become also minus E dot B. So it is odd under time reversal operation as well. So according to our solution, the E dot B is odd under parity and odd under time reversal. So our option C is the correct option for this question.